Alright, for this problem, we were told to find the location of this point here, A, the stagnation point, determine the equation of the stagnation streamline, and the height here above the sink to where the fluid would not get sucked into the sink, so where it just flows uniformly. So to start this question, you want to find an equation for the stream function, and basically what a stream function is just a function used to find the velocities of the fluid that you're working with here at certain points. So in order to do that, it is denoted by psi, and you'd have to add the psi of both a uniform flow and of a sink. And this is obvious because one, there's a sink right here due to the water going radially into it, and also the uniform flow, which is back there. Now we are given the certain equations of u r sine theta. Now this is the equation, the general equation for a uniform flow. This being the velocity, u because it's in the x direction, is the radius from here, and then sine theta is just the angle at which it is from a certain point that you're focusing on. And then for the sink, it's important for it to be negative because obviously water is flowing into it. It's not a source, nothing's coming out of it. It is taking away from the flow. Now, in order to solve this question, you must first find the radial component of the velocity. Now this can be found, the radial velocity can be found using this equation here, which is 1 over the radius of the partial derivative of the stream function with respect to theta. Now when you put that in, you get 1 over and then when after you do this partial derivative here, you end up with u cos theta equals, oopsie, it's not equals, it is minus m over 2 pi r. Now the reason why these r's canceled, obviously this 1 over r here, that's why that r is also there. Now what's also important is to find the tangential component of velocity, since we are working in radial coordinates. Now this can be found with the equation that is given of negative partial derivative of the stream function with respect to r. Now I'm doing this. After doing the derivative, you get value of negative u cos theta minus m over, oopsies, my bad, there's the other one. It would be negative sine theta. As such. Now, using the information given to you here, you can find for the stagnation point on the wall. Important things that you have to note for this is that on the wall, v theta will equal 0 because when looking, sorry, let me move this up. Because when looking at the certain point, there is no velocity there, right? Because it's stagnation point. So the v theta would equal 0, and also the vr would equal 0. And since the main thing we're looking for here is the r, the radius with respect to the slit, we don't need to use this v theta. And the reason why that the velocity there is 0 is because at this point there is counteracting forces of both the sink and also the uniform flow. So as the flow is traveling this way, the sink is pulling something in this way. So it'd be like if two trucks are towing each other at with the same amount of force, they would stay in place. There's no velocity. This thing is stationary. So then when you do that, and you take the equation of VR equals U cos you sub in all the 0 equals U cos 0, because remember v theta equals 0, so everything is 0 with the angles. This can then be rearranged as 2 pi r equals u, and since we're interested in r, that can be written as m over 2 pi u, which then equals, now this is also an important part, in the problem statement we are given 0.1 foot per second as the flow rate per length of the slit, but since it's only a slit, we must multiply it by 2 because it could be seen as half of a proper sink. So the value for m would then equal 0.2 foot squared per second. Sorry, it's kind of hard to see. Then 2 pi, and then u would just equal the given velocity, which was 4 feet per second. Then when that comes out, you get a value of 0.00796 feet. And now this distance here, it's with respect to the slit. So the distance from here to here would equal that value there. Now, the equation for the stagnation streamline, it must be taken with respect to where the point is and the given angle of it as well. So you know that r would equal 0.00796 feet. Alright, sorry about that. My camera cut out again. As I was saying, you have the r. Most importantly, you have theta here, which is 0 degrees. And also, you know that the stream function will also equal 0 because it is the stagnation point. So that helps us a lot. So now if you go back to the original equation that we found here, and you write that out, knowing now that the psi is 0, you have 0, rearrange this, equals ur sine theta minus theta over 2 pi. This can be rearranged into theta 2 pi equals ur sine theta. Now this is an important part to realize here. This r sine theta, you can look at it as somewhat as a right angle triangle, this being r, sine theta obviously being the sine of this angle, and then when you look at this, I said that it also equals this y here. So this can be rewritten as y. And now this is very important because when you realize this, you can then get the final equation here, try to fix it up, of y equals m theta over 2 pi u. So now this here, this is the equation of the stagnation streamline. And now why this is really important as well for the next part. The last component of this question asked, how high must the fluid be so that it does not get sucked into the slit? So now using the previous equation, and the reason why they said what height is because when you look at this diagram again, at a certain height above the sink, the effects of this flow here will not affect the uniform flow up here. So at a certain point, the flow will just be straight like this. uniform, no changes, just going linearly in the x direction. So then when you use the old equation, or the equation we solved for in the last problem, we're given all the values. So m, like I said before, 0.2. And this is also important for theta, because you want the flow to be going linearly like this in the x direction. You want your theta to be things such as 0, pi, 2 pi, and so like you just. But in this case, we need just pi because it creates this one flat surface here. And also in this equation, if we used 0, it would obviously make the height equal 0, which is incorrect. So we use pi. And also this is the minimum as well. Like you could use 2 pi, but that'd be way over the value, and it's obvious that at that sort of height, the streamline wouldn't be affected. So you want to use the minimum, which is pi, and then 2 pi over, use that 4 foot per second again, which was given to us as velocity. Then you were given a value of 0.025 feet. Now this would be respect to the ground level here. So, yep, that's it, and signature just in case. Thank you.